Hello there, and welcome to the new Python video where I will show you how to easily create a nice progress bar using TQDM library. Since this package isn't included in the standard Python library, I'm going to pull it down from the internet. So I'm here in my terminal and I'm going to use pip3 utility to install it. So pip3 install TQDM, and this shouldn't take long. We should be able to see in a second that it's been downloaded. There it goes. Okay, so now I'm going to minimize this and we'll go straight to my Spider ID. And now that it has been installed, we can import TQDM class. So I'm going to say from TQDM module import TQDM class. And first of all, I will show you a few ways in which we can create a progress bar. And later on, we'll take a look at a more practical example where I will download an ISO, CentOS ISO image, and I will build a progress bar around it so that we can track how the download progresses. All right, so the easiest way to create a TQDM progress bar is to actually pass an iterable object to TQDM. So what I mean by that, TQDM, for example, might be a list, a string, a tuple. So let me create here a string variable. I'm going to say text equals to Python is great, no doubt about it. And down below here, I'm going to say new text, and I'm going to set it to an empty string. As I said, to illustrate this progress bar creation, we need some artificial processing, so that's what these two variables are used for. Okay, so now that we have them, we can actually say for char in, and we want to create our progress bar in a loop context. And I'm going to say TQDM, and remember, we are going to pass an iterable object to this TQDM. So I'm going to say here text, because this is our string, and don't forget the colon at the end. And inside the loop, I'm going to say new text plus equals char. So we're going to basically rewrite this string to the new text string so that we have some processing in place. So now that we have it, let's actually run this simple script. And on the right side, you can see already that we have our progress bar, but it went too quick to actually see the progress. Before we move on, let me actually say a few words about the structure of this progress bar. And on the left here, we can see the description, and by default, this is the percentage. In the center, we have our meter, and on the right, we're starting with the total amount of work that has to be done and the amount of work that has been done already. And in the square brackets, you have the elapsed time, the remaining time, and the number of iterations per second. Obviously, we can tweak these settings. We can change the description, we can change the units, etc. And we'll take a look at that in a second. But before we do that, let me actually slow down this progress bar a little bit so that we can see how it progresses. So to do that, I'm going to import sleep function from time module. So I'm going to say from time import sleep. And at each iteration of our loop, we're going to sleep for half a second. And I'm going to rerun this. And as you can see, we are now able to track the progress. We can see how the meter progresses. And I want to point out one more thing, and that's actually the total amount of work that has to be done. And this is a very important concept, because to create a useful progress bar, you need to have a pertinent progress indicator. And in our case, we didn't have to specify it ourselves. We didn't have to specify the total amount of work ourselves, because TQDM did it for us. So when we passed our text object to TQDM, under the hood, it ran the len function on our object, and this way it calculated that the total amount of work is 16. So what it did was running len on our text object. So whenever we pass an iterable to TQDM, that's what's happening. Okay, so now that we have it, let me clear the interactive console here, and I'm going to remove it because it's not the only way in which we can create a progress bar object. We can do it outside of a loop as well. So we can say, for example, pbar equals, and this time we're going to specify the total amount of work ourselves. So I'm going to say TQDM, and we're going to open parentheses. And inside here, we're going to say set total to 1000. So now we're specifying the total amount of work ourselves. We can tweak a few more settings actually as well. So let's set description as well. And this is gonna be my progress bar. And I'm going to change one more thing, and this is gonna be the unit parameter. So I'm going to set it to num. Now that we have it, we can use this pbar object inside a loop. So I'm going to say for I in range, this time we're going to set, this time we're going to do some processing on numbers. So I'm going to say here 1000, and this means that we're going to make 1000 iterations in our loop. Before we move on here, let me create an empty list, since what I want to do here inside this loop, I will append each number within this range to our empty list. So I'm going to say nums plus nums.append I. So we're going to append each number in this range to our list. And we're going to sleep as well, let's say for 0.2 of a second. And remember, we specified our total amount of work that has to be done, but in addition to that, we need to specify the value by which we want to update our progress bar at each iteration. So since this is gonna be 1000 iterations and the total amount of work is set to 1000, it would be reasonable and logical to set it to 1. So to define the update value, you can use an update method on pbar object. So we can say pbar.update, and inside parentheses, you specify the value by which you want to update your progress bar at each iteration. So actually, let me see if everything is correct. It looked like so. So I'm going to run this and let's see what happens. So as you can see on the right side here, we can see that the description has changed. We can see how our meter progresses. And now we can see more clearer that here we have our total amount of work that we have specified, and this is set to 1000. We can see how that progresses as well, and we can see the number of numbers that are processed per second actually. So I'm not going to wait till it finishes, and now we're going to take a look at a more practical example. So I'm going to clear these lines of code here, and I'm going to clear the interactive console as well. And let me copy the link that I have on the second screen to the file that we're going to download. And since we're going to download a file from the internet, we want to use a library that will allow us to do it. So we're going to use a request module. So we're going to import our requests, and I'm going to define our URL variable, and I'm going to paste in this link to the file that we're going to download. And as I've mentioned already, this is a CentOS ISO image, and this is quite big in terms of size. So this is about 7 GB of size. Now that we have it, we can actually make our HTTP requests to this URL. So I'm going to say resp equals, and we're going to use request module and the get method. We're going to pass in our URL variable, and since we're going to stream this download, we don't want to read it all at once into memory because this is quite huge. There is a parameter that allows us to stream the download, and this is called stream. We're going to set it to true, and let me run it actually. Since to make a useful progress bar, as mentioned already, we need to know the total amount of work that has to be done. And actually with request module, if we make this HTTP request, we get a response back here, and we are able to access the headers from this response. And in the headers, we should be able to see the total size of the file that we want to download. So let's take a look at that. If we copy this, and I'm going to switch to the interactive console on the right, if we access the headers attribute, we are able to see this dictionary with data, and one of the keys is called content length, and we are able to see the length of the file in bytes that we want to download. So based on this, we can actually indicate the total amount of work that has to be done, and this is the key to creating a useful progress bar. Okay, so I'm going to say here in our script, total work equals, and we want to fetch this total size. We want to fetch the size of the file. So we're going to say resp. We want to access headers, and we want to access the key called content length. But since if we were to, let me show you what we need to adjust one more thing, because if we, I didn't copy it. If we copy it and if we run type function on this, this will return a string. And the total parameter that we define in TQDM object takes in integers. So we need to cast it to an integer. And to do that, we can simply use int built-in and pass this object to our int function. Okay, so now we'll have this total work in as an integer, so we will be able to pass it to our TQDM without any issues. Okay, so now that we have it, actually, since we want to save this file to a disk, it would be nice to have the name of the file. So what we can do here, actually, on this URL, we can use something like the split method and take the this part of the URL and save it to a variable called file name. So let's do that. I'm going to say file name equals, and on this URL variable, we're going to use the split method, and we want to split this string on the /. When we run this method, this will return back a list of strings. Since this is the last item in this list, we want to access it using the negative index. So we're going to use this -1 to access the last item that's gonna be returned after we're running the split method. Okay, so now that we have it, actually, we can start creating a file object. So to do that, we are going to use a context manager. I'm going to say with open, and we need to specify the file name. So we have it already, so I'm gonna pass our variable that we created. And here we need to specify the mode as well, since this is gonna be a file. Since we're going to download, save a file onto a disk, we want it to be a write in binary, and we're going to save it as fout object. And down below here, we need to actually, we can start creating our TQDM object. So we can use a context manager as well. So what I mean by that, Previously, in our examples, in our contrived examples, we just simply created our TQDM object like this, and we specified our the total amount of work like this, but we had to close it at the end using either the close method on, or we could alternatively delete this object to avoid any issues later on. If you don't want to worry about closing the objects or cleaning them, you can simply use a context manager, and the same as we use here. So we can simply say, so make an indentation here, and we can simply say with TQDM, and we can pass our total amount of work that needs to be done, and this equals to total work that we got here. And remember, this is an integer, so no problem here. We're going to adjust our description. So let's say this is going to be file download, and we're going to set as well the unit. So this is going to be bytes. Since this is a file download, we want it to be in bytes, and we want to as well automatically convert this to gigabytes if that's the case, if that's needed, and TQDM will do it for us if we specify unit scale to true. But before we do that, actually, there is one more parameter that we need to set and that will allow it, and this is unit divisor, and we're going to set it to 1024 bytes. Okay, so let me extend it because we need one more thing. We're going to say with TQDM as pbar, obviously, because we want to create our TQDM object. All right, so now that we have it, we can actually start downloading our file. So what I'm going to do here is create a loop. So we're going to say for chunk. Remember, we want to download our file using chunks. I mean, we are going to split our download into slices. That's why we're using the stream parameter. So what we're going to do here, so far the download hasn't been started yet. So we're going to say for chunk in resp. Remember, this is our response object. And to start the download, actually, we're going to use the method called iter_content. And this allows us to actually, in layman terms, simply speaking, start streaming the file. We can see the description here that it allows us to iterate over the response data, but simply speaking, it will allow us to start streaming the file. So what we need to do, what we need to specify here is to set the chunk size, and we're going to set it to 4 kilobytes. So I'm going to say chunk size equals 4096, and don't forget the colon at the end. And now we have our chunk of data that we pull down from this URL. What we need to do with this chunk is actually write it to our file object. So we're going to say fout, and we're using here the write method. We're writing this chunk of data to our file object. And so far so good, but the only thing that we're missing now is our progress bar object. So we need to specify the value by which we want to update our progress bar. Okay, so to do that, as you probably remember, we want to use the update method on our pbar object, and what we can use here is actually run the len function on this chunk of data, and this will update our progress bar by the size of our chunk. Okay, so what I'm going to do here is pass in our chunk object to the len function. Okay, so now that we have it, we should be ready to go. Let's take a look quickly if everything is fine. It looks like so. Okay, so I'm going to simply run this. All right, so I'm going to run the file, and obviously I forgot to import TQDM class. Okay, so I'm going to add it quickly from TQDM module import TQDM, and I'm going to rerun it. All right, so we have some weird output here. Sometimes it happens in Spider IDE, so let's restart the kernel and it should fix the issue. I don't know why it happens. If you have any hints, let me know in the comments. All right, it's restarted already, so I'm going to rerun it, and this should be fine right now. Okay, so as you can see, we have our progress bar, our meter progresses, and we have our description file download, and you can see that actually the type of unit has been adjusted automatically, and that is thanks to our unit scale parameter. And actually we have everything we need, so you can use it, for example, to download some data from APIs or things like that in your scripts. If you have any questions, let me know in the comments, and I will try my best. I will give my best to answer them. And thank you for watching. Take care. Bye bye.